Guys, I just want to run through these questions, this data booklet for May 26, our paper 2 exam coming up, most likely in half a day, 1 day for many of you guys. These are some of the topics that did not come up in paper 1 or did not come up enough. And so I'm thinking A1, definitely some HHM, simple harmonic motion with springs, right? And we could have angular, um, circular motion, centripetal motion on a banked track. We'll work with the friction. We could have something like that, and changes in kinetic energy loss due to friction. We could be asked to calculate that, and then power. Power is also hasn't come up too much. We didn't see much. Hooke's law. That is again our springs. We could have a circular simple harmonic motion with springs. Next would be our efficiency. So again, if we're having power, we're gonna have efficiency, that's for sure. And that's it for topic A mostly. When we're talking about centripetal motion, we could definitely have something about centripetal motion in an electric or magnetic field. And here is the formula we want to work with, right? This can help us find our velocity or our charge or even our magnetic field strength, right? Or our radius of orbit, right? Or path. And we didn't have much angular motion, so, or rotational motion, so we definitely want to brush up on that, and we'll definitely have something about angular momentum. So that's there, and of course our special relativity, we're gonna have a space-time graph that is certain, and possibly a length contraction time dilation uh, situation that we'll have to work out. World line, understand what the world lines are. And next is our thermal energy transfers. We could have a whole question that links all of these. So topic B is something to brush up on definitely and focus. So we can have thermal energy transfer in system of, let's say it's cooling, tiles, panels, solar panels. We could have a solar sail with photons that hit it. We'll definitely have something about, we'll have 100% a star-based question, right? Calculate the luminosity, brightness, temperature with Wien's law, either of these laws as well. And that will be linked to our topic F, right? We'll definitely need a question about this in paper 2. That didn't come up. And our hydrostatic equilibrium, just fusion process. We were not asked about that. Alpha, gamma, beta decays. That is important. Let me go back and finish our C. Yeah, so B, definitely circuits will come up. We'll have something about circuits, and that would possibly be related to power, as we mentioned back here in A, circuits and power. Parallel circuits will be asked. Then definitely internal resistance, that wasn't considered in paper 1, so definitely look out for that. Then our refractive index, total internal reflection, that's a possibility. And our slits, right? Diffraction gratings, single slit modulation. We'll have definitely a few explain and state questions. What happens if D increases or N decreases? So brush up on those. Doppler effect was covered, but we can have the double Doppler. That could be a question. And of course, our distance of closest approach, that is very important, and that's using this formula. Next would be our stopping voltage for photoelectrons. Now, photoelectric effect and the Compton scattering was covered, but never rule this out, right? Magnetic flux linkage, we had a bit about that as well, but this is definitely an explain question that could come up. Describe what happens, which direction the current flows in, right, as this magnet falls through. And then, of course, this I mentioned, we did not have anything about alpha, beta, gamma, so we want to be revising that 100%. And we just remember the idea that angular momentum of electrons is quantized in amounts, integer amounts of h over 2 pi. And you guys should be fine. Just practice some of these topics and you will be good. Good luck for your finals, and that's it for me.